Hello everyone, Krishna this side. So in this video, I'll be covering this lead code problem 1290, convert binary number in a linked list to integer. It's an easy problem and we can solve this one in different approaches with different approaches. Okay. Now, before proceeding with this particular one, just do let me know if you want any solution from yesterday's lead code contest. Just let me know the problem number in the comments. I'll make sure to upload the videos upon them. Okay. So yes, now just try to focus on this particular one. The problem says that given head, which is a reference node to a singly linked list. Okay, the value of each node in the linked list is either 0 or 1. The linked list holds binary representation of a number. So we have to return the decimal value of the number in a linked list. Okay, the most significant bit in the is the at the head is the linked list. Okay, whatever the current first node head where the linked list is pointing initially, that is the most significant bit. Okay, we have to convert this binary number in decimal formation. So this linked list is like 101, correct, in the first example. So if you try to convert this 101 in decimal form, it is like 5. Okay, and that is something what we have to print into the output. Let us try to see how we can solve this particular one. So let us suppose that this 101 is something what we have, and we have to convert this into the binary number. Okay, how we convert it? Basically, this weight is basically to the power of 0, its weight is to the power of 1, its weight is to the power of 2. So we simply multiply this to the power of 2 into 1 plus to the power of 1 into 0 plus to the power of 0 into 1. Okay, this way we get the answer. Okay, whatever the 5 answer that we are getting it. I think it should be clear now. So going ahead, we will simply having this to the power of 3, 4, 5 all the way till how many numbers that we have. Okay, so yes, it should be clear now. Head is basically pointing at this particular one. So obviously, we do not have idea about like how what is the length of this particular linked list. Okay, so first is like we need to know the length. Then only we can multiply it with 2 to the power of 2 into 1. Correct. That is something what we can try it out. And if you do not have this idea about like what is this length, we have to get the length. That is the first thing. So we can do it in two ways to get the length. The first is like simply convert this linked list itself into the string or string builder. Okay, that way the string is basically looks like this 101. Correct, this is the string, and we can easily get the length of the string. So its length is basically 3, and we are having, if 3 is the length, we are basically required to the power of 2 for this particular initial one. So length minus 1, basically it is 2. So yes, what we will do, same approach, like we will start traversing from this string or string builder, and whatever the current character that we have, 1 into 2 to the power of 2, this particular one, plus this particular 0, the moment we got to the next index, 0 into 2 to the power of this, we will reduce, keep on reducing this value 1. Okay, to the power of 1. Next is like here it is 1 into 2 to the power of this value got reduced at this particular point 0. This way we will keep on considering these values and keep on adding it into the answers, and whatever the answer that we got it by summing them up, that is something what we have to print into the output. Okay, so just to get the length, we simply converted this particular linked list into the string or string builder, which is not at all acceptable, because no one expect you to convert the linked list data in form of strings or string builders to get the answers, right? So only problem here was like just to need we are just required to get the length, right? So we will simply calculate it instead of converting this into the string builder. What we will do, we will simply traverse from this particular linked list. Okay, we will simply traverse from this linked list and keep on counting it, like until and unless head basically points to null. So initially head is pointing right at this location at first index. Here is the head. The count is basically 0 at this point. The moment head started pointing to next, count got increased. Count is basically 1 now. Okay, now the head pointing right over here, count got increased. Count is basically 2. The moment head points to null, we are done, we will go out of this one. So this way the count is basically 2 is 2 is the answer that we got it. Okay, and that is something what we are looking at it, right? So if there is another one right over here, let us suppose 1 is again there, so the count could be 3. Okay, by simply traversing it we can easily get the counts, right? So yes, the moment we got the count, we have to do it the same operation again. We will start from this first node. Okay, so it is like 1 into this whatever the count that we got to the power of 2. Same thing we will do. Head points to this one, here its value, head dot value into the power of 1 plus head pointing right over here to the power of 0. This way we will get the answer, right? We don't have to just convert this linked list into the string builder and then again compute it. It is like just holding extra storage and again performing the same operation just to get the length. We are doing that operation, right? So we will not convert it into the string builder. We will simply get the length. Okay, this is one approach. Okay, one of the approach. Another approach is also there. With the help of bit manipulation also we can solve this. But before that, let us try to write down this particular code. Okay. So yes, what we will do is we will initially create another linked list. Okay, what is this list node, right? This is like list node. Okay, list node. Let me name it as a node. Basically points to head. I don't want to change this head's position. Okay, so I created another node and let us try to get val like how many counts that we have. That is something what we will store it into this val. Okay, now the moment we got this val, what we will do? We will run a while loop and this node, whatever this node dot next, if it is not equals to null, what we will do, we will simply change this vals count, so val plus plus, and node basically start pointing to node dot next. Okay, this way we will get the correct counts that we are looking at. The moment we got the counts, we will again traverse to this one. So again I'll change this node's position to head starting from the first node, and we will keep on traversing through this one until this node is not null. Okay, we are simply considering this count, and let me create here another answer variable, int answer equals to 0. In this answer we will keep on adding the values. Okay, so math dot power, this will be considering this like 2 to the power of whatever the value that we have into node dot val. Okay, that is done. Node basically start pointing to the next node equals to node dot next, and what is this val, sorry, val should get decreased. Okay, I think it should be clear. We are simply performing this, we are simply traversing and we are getting the values, whatever the answer that we are required. Now, once it is done, we'll just try to return the answer. Let me try to run the code. It should work fine. Okay. Yeah, it is getting accepted, and even submitting, it should work fine as well. Okay. Now it is done. This is one of the approach. Next is like with the help of bit manipulation also, we can write down the code. Let me just connect the screen. Okay. Here now we are just trying to see how we can do it with the help of bit manipulation. Okay, so the result is like this, right? Let us suppose 1101. This is the result that we have, correct? And now in this particular one, here it is like 2 to the power of 3 into 1. Here it is like 2 to the power of 2 into 1. Here it is like 2 to the power of 1 into 0, and this one is like 2 to the power of 0 into 1, correct? This is how the result that we have. There is something called left shift in the bit, whatever the bit manipulation concepts that we have. This is like one of the operator which shifts bit by whatever the value that we have right over here. So initially we have 1, correct? This 1 basically got shifted how many times? It got shifted 1 2 3 three times. This 1 got shifted. So let us suppose this head dot val that we have, it got shifted 3 times. Okay, so head dot val is basically 1. 1 got shifted how many times? 3 times. That is like 1 0 0. 3 bits are something what we will put it in front of this one. Okay, so any value that we have here, if it is 1, okay, so let us suppose 1 got shifted by 1. That means initially 1 is basically represented in this way, and if it got shifted by 1, how it looks? In front of 1 we will add 1 0. If it got shifted by 2, in front of 1 we will add 2 zeros. Okay, if it got shifted by 2, if it got shifted by 3, 3 zeros is something what we have to consider in front of it. Okay, this way this left shift operator works. Now we have these values. Okay, the first index basically got shifted 3 times while traversing this, particular list. We will keep on shifting these bits. Okay, whatever the new bits that we are getting it, we will keep on shifting it. And there is another or operator that we have. Okay, so if the values are something like this, let us suppose 110 is something what we have, and we have this or operation that we have to do with 1. Okay, so what is this value, new value that we got? This is the or operator. So it is like 111. So at any point, if there is any set bit that we have, the answer is basically 1. Okay, if both the bits are 0, in that point in only, the answer is basically 0. Or else at any point in time, if 1 is something what we have in the bits, the answer is basically 1. Okay, considering these all the facts, what we will simply do, we will create a result answer. Okay, result is something what we will create. Okay, whatever the answer that we are looking at, and this answer basically gets updated by this head is basically pointing at this particular one. So answer is basically result is basically one initially. Okay, result is basically one. Now we will keep on traversing this. Here it is pointing. So whatever the result that we have, it needs to be get shifted by one bit. Okay, one time. So result is basically one shifted one, and this particular one is something what we will OR it. So here how it looks like 1 0 and 1 is something what we have. Okay, 1 0. Okay, it got shifted by one. That means like 1 0 and 1 is something what we have. It is lagging a bit, but anyway, I'll just cover it quickly. So this is basically 1 1. Okay, that's how it looks like 1 1. Now again, this result we have to shift it by one, and whatever this bit that we have, we are simply traversing it, right? So this is something what we will OR it with that one. Okay, OR with that particular 0. So this. Yeah. So this how it looks like 1 1 0, and or with 0 is basically same. 1 1 0 is the result that we got. Okay, 1 1 0 is the result that we got. Again, this result needs to be shifted by one bit because all these bits are getting shifted by one bit, right? So whatever the value that we have, it needs to get shift by uh I mean whatever the bit, this particular bit needs to be shifted by 3 times, this needs to be shifted by 2 times, this needs to be shifted by 1 times. So this while going ahead, it will keep on doing that operation. Okay, that means like this is basically got multiplied 3 times, this got multiplied 2 times, this got multiplied 1 times. That is the operation it basically does. This left shift operation, whatever we are doing it, it will basically resemble that way only. It's like we are simply multiplying it with 2. Okay, so initial first bit needs to be multiplied 3 times, so initially only we will multiply it, and then we will OR it with next bit. Now whatever these 2 bits we have to multiply it with 2 again, and we will OR it with the next bit that we got it. Okay, this way we will keep on building the result, and ultimately the answer that we will get is like when this entire result that we got it again, when we lift it with 1 and or this with last bit that we have 1, the answer is basically look like same 1 0 1 0, and this result basically computed it. It's a binary number. This is the binary number. Its decimal number is like 3 8 10 and 11. 11 is the answer that we will get it. Okay, so it will automatically consider the answer. Okay, so I guess this should be fine. It should be 11, and it is taking time to update. But yes, we will simply try to convert the same whatever the values that we have into the binary formation of the number while using the bit manipulation. Okay, so let me try to write down the code. Let us suppose int answer is something what we are having initially. Answer is basically pointing to head dot val. Okay, if there is only one value that we have, definitely that is something what we have to return into the output. So let us try to return the answer. Now we will traverse through this head while head is not equals to null. Okay, head dot next. Okay, currently head is whatever the value that head we have, we got it. So head we will simply point to the head dot next, and that value, whatever the value that we have at that particular position, that is something what we will add it into the answer. So answer equals to, answer needs to be shifted by one bit, whatever the answer that we have, and this head dot value is something what we will OR it with. Okay, so initially the first one is something what we have into the answer. Okay, I think this is all that we have to do, and that is something what we have to print into the output. Okay, it's pretty much clear and simple and straightforward. Whatever these values that we have, we are simply converted into the binary formation. Okay, and we are dealing it with. So how it looks like, the answer is basically 1 initially. Okay, and then we shifted it by one bit, so answer is like 1 0. This is like again binary formation. Okay, and when we do OR with this 0 value, okay, next bit is 0. Okay, this while performing this basically looks like this only 1 0 in form of binary representation. Okay, this bits definitely it will convert it into the answer in decimal form. Okay, internally. So 1 0 is something what we got. Okay, in the answer, that is like it's 2, its value is basically 2. Now again this 1 0 head is basically started pointing to the next, 2 left shift by 1. Okay, and we are just or performing this OR operation with whatever the next bit that we have. Okay, this will be like again 1 1 1 0 0 or 1. This will looks like this way 1 0 1. Okay, ultimately whatever the value that we have, we are just trying to convert it into the binary formation. This will automatically inside this answer gets converted into the 5. Okay, this way also we can solve this particular one. I hope this should be clear to you all. And with this, I think both the approaches should be clear for right now. And never try to convert any linked list into the strings or string builder, because that is something never going to help you, even in the form of arrays, something like that. Just try to consider this linked list and perform the operations. This way only you can get the solutions and will get accepted in interviews and all. Okay. I hope this should be clear for now, and just do let me know if you want solutions from the yesterday's lead code contest. Any particular question that you are struggling to understand, I'll make sure to upload the videos. Okay. Thank you for watching this video. Bye bye.